The last video, we built the MCP server, the incident server, using the fast MCP server with the fake order and inventory data. We had 3 tools like get order, check inventory, and notify Slack. Check inventory in particular was sleeping for a few seconds, so you can see the slow span in Jaeger and returns a back order error. As we saw, also the server runs the sub-process over stdio. The std-in and the std-out carry a JSON message. There was no HTTP there. The server is done, and also the tracing on the server is done. Now we will add the DSPy agent, replacing the crew AI agents in that program, and we need to see how the DSPy will perform in the same example. So we need to create a new file for the server. We will call it MCP session context. We will start by importing some of the libraries that we will use in this module. For example, the sys library and also the sync iterator. From the context lib, we need the async context manager. We need to get the DSPy, and from the MCP, we need to import the client session. Also the stdio server parameters. From the MCP client stdio, we need to import also the stdio client. So we will use a decorator async context manager. This decorator turns the function into an async context manager, meaning callers use the async with MCP session context, and they will get the session and tools. The async iterator type hint here signals that the yields will be exactly once. So everything before the yield is set up, everything after, if you add it, would be the tear down. The reason you want a context manager here rather than a plain function is that you need a guaranteed cleanup. The sub-process and network connection must close even if the caller crashes. So here we need the parameters. We need to initialize the parameter from the stdio server parameter. This is just a config struct. So we have the command, which will get the sys executable command. It's a deliberate choice. It means use the exact same Python interpreter that's running right now. So you can get the same virtual environment and installed package in the sub-process. If you hard-coded Python, you would get whatever Python is on path, which may be different version or missing your packages. Then we have the argument, which is a normal packaging -m for the server's incident server. So this is a sub-process that will be called, and also we don't need to pass anything for the env. Now we have to open the context for the stdio client. This is where the sub-process actually spawns. The stdio client launches the command, then it yields 2 async byte stream objects, the read and the write. Read is an async reader connected to the subprocessor stdout. Your client reads responses from here. The write is the async writer connected to the subprocessor std-in. Your client sends request here. Think of it as the 2 half pipes forming a full duplex channel. The MCP protocol writes over these raw bytes. You never touch the bytes directly, and the next layer handles everything. So we see here that the client session, which initializes with the read write, it will take the raw streams and puts the MCP protocol on top. It handles JSON RPC framing, messages, IDs, request response correlation, all the plumbing. From your code's perspective, after this, you can call high-level methods like session.call tool and something like that, and get back the structured result with 0 byte level code in your part. We have to call the session initialize. This is the MCP handshake. Client and server exchange capability negotiation. They agree on which protocol versions they both support and what features are available. For example, whether the server supports streaming, resource subscription, etc. This must complete before you call any tool. Skipping it will leave the session in uninitialized state and the server would reject your request. Then we need to list the tools in the session. So it will send the tools list request to the server and get back the list tools result. The .tools attribute is a list of tool descriptors. Each has a name, a human readable description, and a JSON schema for its input parameters. This is the server advertising its capabilities. The client discovers them dynamically at runtime rather than hard coding them. What we will do here in the list comprehension is calling the DSPy tool from MCP tool, which is the bridge between MCP and DSPy. For each tool descriptor, it creates a DSPy tool object, which knows the tool's name and description used by the LLM to decide when to call it, and captures the session in the closure. So when the LLM invokes the tools, the call is routed through session.call tool back to the subprocessor over the stdio pipe. The list comprehension runs this for every tool, giving you list DSPy.tool that you pass directly to the DSPy ReAct. Calling the yield session and DSPy tools, so the function will pause here. control back to the caller. The caller can use a session and tools for as long as it needs. When the async with block exit, whether normally or via an exception, Python resumes after the yield, and both client session and stdio client context manager unwind. The session closes, the pipe flush and close, and the subprocess is terminated. This is exactly why the context manager button exists here, to guarantee the subprocess doesn't become an orphan process. So we need to have a new package here for our DSPy incident agent. So we call it the DSPy incident agent. And we need to have it as a Python module here. So we need to add the init file, the empty init file. We will call our module signatures. We will create the DSPy signature classes in this module. We need to import the DSPy and then create our incident investigation DSPy signature class. So it will inherit from the DSPy signature. We need to add a doc string for this class. So the doc string, as we know from the previous videos about DSPy, it will act as a description or instruction, like a system instruction for the DSPy class. So we need to make sure here to add any instruction that we need to add it to the class. So the DSPy agent that instantiating this class will consider it in the LLM call. So here the client will be on call incident investigator. So we are supplying the MCP tool like the orders and inventory, and to make sure that always to call the order first and then check the inventory for the orders SKU. And we don't need our agent to guess anything, so never guess warehouse stock. So we will have only two fields for this class. So the user request will be the input field. The process result will be the output field. The process result, we need to have it in a form of 3-5 sentences. So it will be a summary about the order status and the inventory finding. Also, we need to have some summary about the root cause and a recommended customer message. There is additional fields like the reasoning and the trajectory that the DSPy signature will create for us. We will see how to use it in the next module. So for the last module, we need to have our demos here. So we will create the incident agent demo. We will start by importing the libraries that we will use. So the sync library, the sys library, traceback, also the DSPy library. We need to get all our implemented modules like the incident investigator and the configure telemetry, also the MCP session context. We'll start with the first helper method here. So print trajectory will help us pre-print the trajectory that come out from the DSPy agent. So the DSPy ReAct stores the trace in a flat dictionary rather than a list of step objects. So the keys will be in a form of the key string underscore the step number. So it's like thought 0, tool name 0, tool args 0, and so on. It's a flat because these POI prediction objects are essentially type dictionaries and nested list. And nested list would complicate serialization and teleprompter optimization. So we need here to just have a while loop with a true break button. So this way we can walk over the structure. We need to increment the step every run. The keys will be the key name underscore the step. So we have the thought underscore step, and also for the others like the tool name, the tool args, and the observation. If there is no thought or tool name, we just need to break it out because sometimes the final step has a thought, but there's no tool call. The LLM reasons its way to an answer without needing one more tool. And we need to print all the fields here if they exist. The observation function could be a long text. Here is a practical choice. Just the to response from MCP server can be very large and it will be very hard to print it. So we just here cap it to 200 characters, which gives an enough summary of the field content. For the other important function that we will use in our demo, it's a investigate incident. It will take the user request and return the DSPy prediction. So first we need to configure the telemetry for this function. We will have a new service name. Let's call it the DSPy incident agent. And the instrument DSPy will be true. We need to configure first our LLM. So we will call the DSPy configure using the LM fields here. So the DSPy LM will have the model for our OLAMA. We can use GMA 3 here. The API key will be just OLAMA. We don't need it actually. And then we have the API pays, the max token, and the temperature. We need to open the session for the MCP session context that we prepared in the previous module, and we will get as a result the session and the tools. For just a quick verification, we will print out the tool names here. We will have the tool names extracted from the tools, and then we print it out with the user request. So a few words about React here. So React, the reasoning and acting, is a prompting strategy where the LLM alternates between two things on each iteration: emitting a thought, free text reasoning step, like I need the order detail before I can check the inventory, and then acting on it. So picking a tool and arguments and call them. After the tool runs, the result become an observation that gets appended to the prompt, and the LLM reasons again. And this continues until the LLM decide it has enough information to emit final answer. The alternative would be to give the LLM all the tools and ask for one shot. React is better when the task is multi-step and the right next tool depends on what the previous one returned. So here for our agent, we will have the DSPy ReAct, giving it the incident investigation signature and passing the tools, having a cap for the iteration to it. So this will take the signature class, which defines the input field, the user request, and the output field will be the process result. Then we need to have our agent running. So we need to wait for the agent.sync call or the A call. And this is the async version of the agent initialization call. These DSPy modules are synchronous by default, and the A call is the async variant that can be awaited, which matters here because the whole investigate incident function is async and the tool call goes through a sync MCP transport. If you use the sync call here, it would block the event loop while waiting for the subprocess to respond to each tool invocation. Then we will have our main function. In this main function here, we will have just a short user request, which we will request here to investigate the order number that we know it has some kind of problems. And we instruct to call the get order, check inventory, and then summarize the result. For that, we need to have the async IO to investigate incident, get the result out of it, and then we need to print the process result and the reasoning if it exists, also the trajectory if it exists, using our print trajectory helper function. So we need to run the script, we need to run the demo in the incident agent. After the running is completed, we can see from the log here that all the traces has been logged out. So starting from the request that we are printing out, and then all the tracing in the DSPy itself, calling the tools from the get order, from the inventory, and then we will have here the result from the DSPy object, in addition to the reasoning. And then we will have the trajectory, and we see here that we had two steps. We are printing everything regarding the observations and all the other fields. If we have a look at the Jaeger, we can see here our DSPy incident agent is now a part of the services that we logged. And if we logged in the last DSPy incident agent trace, we can see here all the LLM interaction from DSPy, the tool calling from the MCP. We can see here all the payload, response from the MCP with the delayed SQ order. And again, we can see also the check inventory error event that is being created by the MCP server for the delayed order or for the delayed SQ. So we have a full trace about all the errors or the logs or the events that happening in the MCP server, and also the LLM interaction from the DSPy itself. And till we see here the completion event from the DSPy is all the system prompts and user prompt again to the output value for the reasoning and the process result. Thanks for watching. If you want more of this, like the video, subscribe with the notification on, and share it with your friends. We release new videos every week on AI development, agents, and developer tooling. Thanks for being here.